So welcome to the first vericast for this cohort. I hope you're doing good. And my name is Tejumade Afonja. Some of us met me last week. It's a pleasure to be your instructor for this week. So today we'll be going over introduction to data science. But before we start, with a show of hand, can you raise your hand if you went over the notes that I shared on Slack? Okay. I see a couple raised hands. That's good sign. But still very few. Okay. This is good. This is good. Thank you. I'm really glad that most of us did go over the material. It's good. So yeah, you can stop raising your hands now. Thanks, everyone. So for those of us who went through the material, what do you think about it? You can use the chat to kind of like talk about how did you find the material? Was it easy to read? Was it hard to read? How long did it take you to finish reading it? You can also unmute if you would like to speak, or raise your hand and I can ask you to speak. Oh, I see a couple messages on chat now. Just comprehensive. Someone can't hear me. Can everyone hear me? Am I audible?
Yes, I can hear you.
Thanks, Mustafa. Okay, so I see Babalola said it was comprehensive. The materials was easy to read and engaging. It was really relatable, lengthy, but kind of interesting. Took me an hour to read. Okay, yeah. Did it take, oh, no audio. For those of us experiencing audio problem, maybe you should restart your Zoom. It might be that Zoom was just acting up. But in general, it seems like everyone can hear me. Good morning, Chuzum. The material was really nice in a way that it's easy to understand, as I just started going through it yesterday night, but was also able to finish it yesterday night as well. Yes, thank you, Femi, for going through the material. I also think it's really easy to read. I like Professor Zico's notes. I usually just go over the notes and I learn new things every single time, even though I've been taking this particular, like we've been using this material for the past 3 cohorts. I still reread the content and learn something new. That's the beauty of, good materials. You always go back and you get new insights every other time. So thanks everyone. Thanks everyone who went through it. I think this is important because it gives you a broader view. What I'll be going through would be the slides. I'm using the same slide from Professor Kota, but I've added maybe a few slides of my own. So today's class is very chill. It will be mostly us talking and thinking about data science and, coming up with our own definition of what the entire field is, what are the applications that you've seen that has interested you so far. So it's going to be very interactive, and I hope we can make it very interactive. So yeah, let me get to it. As I've mentioned, slide credit is to Professor Kota, and it's one of the materials that we will be using this cohort. Will mostly be resting on the shoulders of this amazing content that's been curated for us. So today I'll be talking about what is data science, not me talking about it. We will all be talking about what is data science, like what does data science means to you when you think about it. But we also talk about what data science is not and give a few examples because the field is so diverse and it seems like the data science word is just a buzzword or whatnot. You don't even know what to call yourself. Should I say I'm a data scientist or engineer or practitioner? I definitely had that problem when I just started out. I just wasn't sure what it was that I could categorize myself as. But as you grow in the field, you naturally see where you belong in that realm, and you can you can label yourself much more appropriately, whatever label you think suits your skills. So we'll also be looking at a few data science examples, and lastly, we'll just be discussing and some administrative stuff. So if you have any question, feel free to unmute and ask, or use the raise hand button if you feel like you don't want to interrupt me. Or you can also use the chat. Because I'm only using one screen, it's possible that I might not see the chat as often as I need to. So if someone can nudge, just like unmute and kind of like class captain, let me know that I have questions in the chat and I can quickly go to check it. And so for today, I will be assigning the class captain myself. Simon is on the call, so I'm assigning Simon as class captain. Simon, would you be able to resume office for today?
Okay, Teju, I'm multitasking right now, so it might be
Okay.
difficult.
Okay, no
Yeah,
problem, no
I'm
problem.
multitasking.
No,
Okay,
it's okay,
thank
Coach.
you.
I understand. Thanks for joining the class,
Yeah.
irrespective. By the way, everyone, Simon is one of our co-organizer, and he's also one of he's on the team for this cohort 7. So thanks for joining, Simon. Okay, I don't want to put anyone else on the spot. Who would like to help me?
Let me go.
Who is saying something? Chisholm.
Yeah.
Okay, thank you. Thanks, Chisholm. So you just kind of let me know if there are chats or if I've missed something. So I see Dotson said that everything was interesting, brush up, read it, but could not finish. Okay, is there a reason why you couldn't finish? Was it because the material was difficult to finish reading, or you just didn't have the time? I just want to understand. Okay, while Doctor reply my message, I look at Hamza. Hamza said that I would like to know the difference between data analysis, data science, artificial intelligence, machine learning, robotics. Yeah, it's just yes, there's definitely differences between those, but they also intersect in some point. Okay, yeah. So today definitely talking about data science. We'll talk about. Okay, to some of us, my audio quality is not good. Am I audible to everyone? Fairly everyone? Or is it the same for you?
I think your audio is good, like very clear on my side.
The audio is good.
Yeah. So if you're having audio issues, which is normal, just restart rejoin the Zoom, restart it. But your audio is actually very okay. At least I can hear you clearly.
Okay, thank you, Femi, for the feedback. All right, so I was talking about Hamza's question. We will go over data science. I'll talk about the task of data analysis, kind of give how they all come together. Of course, artificial intelligence is out there everywhere. So we'll also talk about a little, not really talk about it. It's more like, okay, yes, artificial intelligence is mostly when you're thinking of AI, you're thinking of, it's not narrow AI in terms of machine learning or just doing some learning from data, but more like mostly thinking about how you can build an intelligence machine, so such of something that can think like human. So the artificial intelligence came in because people wanted to build machines that has almost the same functionality as the human would do. So that's you can like see a lot of sci-fi where you see things like C3PO, if you're a Star Wars fan, which can talk and reason. But that's a broad AI. But then some people like to classify narrow AI that does not exactly replicate intelligence, but can still do the task that human would find. You were like, oh, a machine did that. Amazing. So we also, robotics as well. And yeah, we will try to kind of like make this class interactive, and we can all give various definition. Maybe some of your colleagues will be the one, like I'll be asking you what you think robotics is. Maybe we start with that, and we can move on. Let's quickly look at the rest of this charts before I delve into this material. So good material, but somehow advanced to some of us that are just taking up the journey. Okay.
Yeah.
Advanced. How do you mean advanced? I'm trying to understand. Well, was it too technical? Or or some of the things that it talked about, you weren't very familiar with them? Because it seems like the material was just like talking about data science as a whole, what data science is not, just to clarify, because there's always this debate about like, is machine learning data science, is data science not machine learning, or all of those things, is it artificial intelligence? So I think the material was trying to explain that the idea of data science and why you need the science in it to be able to say it encompasses all of it, all of the process from collecting data to deploying. So it's not just the algorithmic part, which machine learning is mostly focused on, but it's the entire pipeline. So okay, I can hear you loud and clear. Okay, so I think that's all the
That's all the question.
Sorry, go ahead.
I mean, that's all the question. I would always message you personally.
Thank you. Thank you so much, Chisum. So yeah, let's continue. That was good. Thanks for those interactive questions. If you have more questions, please feel free to put it on chat. There are no weird questions. If something you don't understand, ask. Someone else probably have the same question as you do. So you're helping them out actually by asking. Oh yeah, I don't want to go down first. I want to ask you, what is data science to you? What is data science? And we'll take a few answers. Please use the chat to put in your answers. Just do that exercise together. What is data science? If someone asked you, Chisum, what is data science? How would you say it? How would you explain it to the person?
Okay. Good morning, guys. Can everyone hear me?
Yes, yeah, I can hear you. Go ahead, please.
I think data science is the intersection between math, probability, and programming.
Mm-hmm.
Yeah, and it's from one of this course on Coursera that I actually learned this.
So why is it intersection between math, probability, programming?
Yeah, because basically,
because it just seems like we moved from one definition to three other things. Why does that define data science?
Because everything has a foundation, and then the foundation of data science over the years has always encompassed these three things: mathematics as a subject, statistics as a subject, and programming as a means of solving problem.
But wouldn't can't we argue that statistics is mathematics? Are they two different things?
Actually, for people who are into mathematics, I don't think they would agree that statistics is mathematics, because at the very core of it all, they start getting quite very, very different when you study them in depthly. So we are just having it as studies in our universities because there's no way to go around that. So we just have to put them together. But they are actually different fields that have some basic foundations.
So if I were to drill you a little further, what are the core things that you would say, this is why mathematics is mathematics, and this is why statistics is not mathematics? So what would be the differentiating factor?
Okay, so basically what would be the differentiating factor is that mostly in mathematics, there are some, there's a theory proven by, I don't know his name, Hegel, that states that the theory of trying not to solve a problem, like some problems are actually unsolvable, but then in statistics, they are made bare with numbers and representation. So you would always come to a conclusion of something in statistics, but then in mathematics, you don't always come. And even if you do, it can be disproved.
Yeah. So the field of mathematics, you have mathematical model. It's all about proving, and I mean, not all. I'm not a mathematician, but as far as I know, so you don't need to come to an exact solution. Like, it gives you a framework, like a model. Like mathematicians, they give you all of the proof, and then it's possible that when you try to solve it, like maybe you don't come, like in the real world scenario, you don't come to the exact solution, but the proof works, like theoretically. So, and I might be I might be misrepresenting mathematics with the way I've just simplified it. I apologize if I just did so. But yeah, you were right on point. I just wanted to allude to your point that this idea that in statistics, like everything is about numbers, right? We need to be able to quantify things. It's always like trying to understand, playing with numbers, statistics and everything. In mathematics, it's a little beyond that. So statistics definitely uses it's a field that was born under mathematics, you get, but it's not, it's a subset of mathematics, but mathematics would be the superset in this case. Okay, thanks, Chisholm. That was good. That was interesting and a good answer. Thank you. So someone said that science is the intellectual and practical activity encompassing the systematic study of structure and behavior of physical and natural world through observation and experiment. I feel you, Tayo. Can you explain it to us? So how does data science encompasses all of this intellectual and practical activity? How would you say that data science make that happen? Or would you say it doesn't, so it's not data science? Curious. I'm curious.
The reason I had to put down this definition
is
because
your audio is very low.
Hello, can you hear me now?
Yes.
Okay. So the reason I had to put up that definition was to bring about the understanding that the science of data is data science. So what exactly does the word science mean? So anything that involves an intellectual and practical activity where you study structure, you study changes, you study behaviors, you study how things interact and what are the patterns you can draw out of them. That is what science does. So when you're saying data science, I believe data science is that field that tries to achieve that effect working on data. And to do that, then it borrows knowledge from statistics, knowledge from computer programming, domain knowledge or expertise, and a few other things. But the end goal is to achieve this on our data. That's it.
Exactly. So yeah, there's systematic way of studying, so empirical. So you go from observing data, trying to make inference prediction, trying to learn all about the data. There was a quote that I saw, it said, basically you become one with the data. So it's like the science of the data and everything. Yeah, I like this. I like this definition. Thanks for like bringing it to the core of it, like what is science itself. And then we can now see what data science is and how we as, I wouldn't call myself data scientist because I mostly work with machine learning algorithms. So about how data scientists come about their field of, this end-to-end process of doing science on data. So another, Umoran said that data science is using data by analysis. Okay, no, but analyzing it, drawing inference from it, and creating solution through it. Umoran, do you want to say a little bit more about this?
Yeah, hi, good morning.
Good morning.
My name is actually Amazing Grace. It's my surname.
I'm so sorry. Thank you for correcting me.
Yeah. So I believe
Amazing Grace. Oh, I'm sorry. I got carried away. Go ahead.
Data science is like, like a merge of data analysis and data visualization and model building and everything. Like you collect data, you analyze it, you draw inference from it, you observe trends, then you create models that build solutions, like solve real life solutions. That's what I think data science is.
So thank you so much, Amazing Grace. So this is already answering one of your colleagues' question about what's the difference between data analysis, data science. You just told us that data science is this process of the entire process of saying data analysis, visualization, modeling, inference, deployment. You just define data science as all of the things, a sub-process, the things that we would do that makes it a science, basically. Okay, yeah, we move on. Thanks, Amazing Grace, that was good. So data science, Adidaya said, data science is basically a field that involves the use of statistics and computation to solve and understand real life problems. Yes. This definition we'll be getting into in the course. Thank you, Dayo. And maybe a few more before we continue. Data science is the science of gathering data, whether structured or unstructured, to derive insight from it, which in turn is used for making decisions. I agree. Data science is the science of data. Very, very, very real. To me, Shadrach, data science means applying statistical tools to get information from data and use it for either the present or future. Yeah, data science is the heart of processing of data, visualizing it in real world, process of turning raw data using computation and statistical method in something useful for human. It's an interdisciplinary field that uses scientific method, processes, algorithms, and systems to extract knowledge and insight from noisy, structured, and unstructured data, and apply knowledge and actionable insight from data across a broad range of application domain. This is a much more detailed definition, but you can already see the same theme. Like you hear statistics, you hear computation, you hear data analysis, visualization. If you were to kind of like put keywords together, you already see what data science means to different people. And this is exactly what I'm trying to get across. Like, data science is not one thing to everyone, but it's like have multiple definitions. It's one of those topics that's hard to define. You can't just say it is this thing, but at the end of the day, we can all agree on something, we can all agree that it involves you collecting data, analyzing data, visualizing data, then making prediction on that data, and also furthermore deploying that data. So it seems like we all agree on this central theme of what data science is. Yeah, thanks everyone. Sorry we couldn't get through everything, but I promise you I'm going to put all of this, your definition, as a post, as a blog post, and that will be our first blog post, because I think those are really interesting and we're not going to lose the definition. So you can continue to read it. So what is data science according to this definition? Yeah, welcome back, Shola. So you see, data science, you can say, oh, it's the application of computational and statistical technique to address or gain insight into some problem in the real world. Okay, and what are the keywords here? Computational, statistical, real world. So it's like you need to have some data in the real world, and you need to make some computation on this data. And if you want to make computation, you kind of like go to borrow some techniques from statistics, because that's like their bread and butter. That's what they do for a living, right? But it's just beyond that. You're not just trying to like do the statistics on this. You want to, of course, gain some insights from it. It means that you probably need to make some presentation. You need to present your results. You need to have some hypothesis as to what the data is doing and what it is not doing. So all of those process, it's a scientific process. You hypothesize, you find evidence, you come back to conclude, you experiment, you do conclusion, something does not work right, you collect more data, you do the process all over again and again. And so you can see that it's beyond just like having some data and just doing some computation and say, okay, yeah, here are the numbers, make do with it, whatever it is, it's okay. No, as your job as a data scientist, it goes way beyond that. It's all of it, basically. So so let's come here. I'll say some possible definition. You have statistics, data processing, machine learning, scientific inquiry, visualization, business analytics, big data, blah, 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 blah. So much of it out there. And so before we come here, I think I lost one slide, but it's okay. We can use this other slide. So the slide that I lost is supposed to show you that data science is like the sexiest job in the United States. So it's actually one of the highest paying jobs in the United States. So I decided to also Google search that highest paying job in Nigeria, just to see if data science, to say maybe you should abandon this thing that you are learning now and just find another job. Just joking. But I found out that we are not quite there yet. We don't have a lot of data scientists making a lot of money at the moment, but it will change in the very near future. I am almost certain of it, because we have massive amount of data now, and we need to be able to understand it. So, and it means that the people that are going to do that job is no other people than you guys. So it's good. It's very important that you're learning these skills now, because it's gonna help change your life, basically, if you believe in life-changing opportunities. So according to this link that I found, the top 25 highest paying jobs in Nigeria are this. So it's it's too late for me to be a surgeon. I mean, never too late for anything, but I'm not so much of a medical student. But anyway, going down the list, I saw that maybe it's not bad. Software developer, still high paying, but we definitely need to do something about this. Try to put in more jobs there. And 153,000, it's not so much as a high paying job, to be honest, if I'm being fair. So 25 best job in America. You can see that like data scientist is like one of the top best jobs. Yeah, so software engineer, nurse practitioner. It seems like the medical field is a really, no wonder like our parents will be like, you have to be a doctor or an engineer or something. They know what they are doing. Anyway, you can also see speech language pathologists. What did they do? Speech language pathologist. Does anyone know? Nobody. Okay, I have to Google it after. I'm sorry,
Actually, somebody knows.
your audio is
Somebody.
Somebody that trains all these celebrities, going like well, then get better.
Can everyone hear him? I'm struggling here. Could you please speak into your microphone?
I said I'm thinking those guys that train celebrities and audio artists when they are presenting to get better audio, like vocal sound.
Okay,
Like
okay.
treat their voice, vocal.
That makes sense. That makes sense. That would be a hot job.
That's a very niche job. Niche, like
Oh yeah,
very
yeah, that makes
specialist
sense.
kind of
You're right. All right. Thank you. Okay, so now that we've talked about what data science is, we have all of this different definition, and so we want to discuss what data science is not, what is data science not, what data science is not. And Professor Coulter was so generous in giving us some example. And in his notes, if you read these notes, he also linked to this post called 50 Years in Data Science. I read that essay. Can I call it essay? No, is it a publication? Like, I mean, it's a research paper. Yeah. So I read that paper, and I found it hilarious, to be honest, especially the first couple of pages, because it was kind of like talking about how data science has evolved over the past 50 years, and how someone, I forgot his name, I think he's from the electrical department, and I forgot his detail. But what I want to talk about is that they've been talking about this idea that statistics needs to be broader. Like they need to do much more than what they are doing, statistician, but they never really evolved. They never really changed the way they are doing stuff. And all of a sudden, data science, machine learning just came, and it wasn't even really born from statistical department. And it seems like everything that data science, machine learning, and everything is doing is like what statisticians have been doing for like a long time, and it's just now another name. So it was definitely the paper was quite enlightening for me. It just helped me appreciate these fields, like the field of statistics, machine learning, data science, and understand a little bit more about how experts out there are thinking about this problem. So if you want to or have some time, you can have a look at the paper. I think it's interesting, at least for me. So from there, he also talked about what data science is not, and this all of these weird thing that you see, or like the buzzword that you see online where it says data science is just big data, or data science is machine learning, data science is this. So this is the same. I think this is where Professor Coulter drew the inspiration for this slides, upcoming slides from. So here it says that data science is not machine learning. And before we go into it, what do you guys think? Do you think that is true?
Could you pause a bit to get some people's feedback? Hello. Hello, Taju.
Hello, I can hear you.
Yeah, I mean, could we possibly to get people's feedback? They've been raising their hands.
I'm so sorry. I didn't see that. Okay, please go ahead.
No,
Yeah,
my hand was straight from earlier question. I'm sorry. No, I don't have any question.
You don't have any questions? Okay.
Yeah, and then there's Chris.
Chris, please go ahead. Okay.
Yeah. Good morning.
Good morning.
Yeah, sorry, I got distracted at some point, so I don't know what we're talking about. I had to attend to something briefly.
We are talking about data science. So what do you think of data science? To you, what is data science?
Well, to me, basically, it's just you are analyzing data, either and you are sort of reorganizing data to suit with a particular goal in mind, to achieve a particular goal.
Mm-hmm.
You are more like, be it structured or unstructured, you are just integrating it together and trying to create it to something else to achieve a particular goal.
Yeah. Well, thank you, Chris.
Huh?
Hello.
Yeah, hello. Yeah,
Okay.
I'm here.
I said thank you. Thanks for that definition. And Tayo, thank you so much for the SLP definition that you just gave here in the chat. It says that it treats many types of communication as swallowing problems. Yeah, thank you. So I wanted to also make this part interactive. We said that data science is not machine learning. Guys, what do you think about that? Do you think that is true? Why would data science not be machine learning? It seems like machine learning learns from data, right? Or learn some pattern from data. Data science is the science of data. It also learns from data. So why is data science not machine learning? Anyone? You can also use the chat.
Try.
Yes, please go ahead.
Well, I think data science is partly machine learning, but not fully machine learning. And machine learning involves algorithm and really in-depth of model building, I think. But data science doesn't really care about the model building aspect, just what you can do with data and solutions you can get from it. That's what I think.
Well, thank you. Thank you so
Can I
much.
say something?
Okay,
Yeah,
sorry.
okay.
Okay, maybe you go first.
Can I say something?
Yeah.
Hello. So data science is not machine learning. Machine learning is how will I say? It's the ability to improve the decision making of a tool. But data science, on the other hand, is collection and processing of data to make to solve real world problems. So I don't think the both of them are the same. While they are closely interjected, they are not the same thing.
Okay.
Okay.
Thanks a lot.
Sorry if I may add to that.
Yeah, please go ahead.
Okay. I think the difference between data science and machine learning, it's basically because machine learning it's more like computer learning by itself. It's an automated process where you give your computer some data, and then you make the computer learn from your data so that it can by itself identify patterns and then understand the data on its own. While data science is different because data science is just drawing inference from your data. It could be inference about the past, descriptive. It could be inference about the present, or it could be inference that helps you make business goals prescriptive. So I think data science on its own, it's what we use daily on our day-to-day life experience. For example, we know that we want to wake up every day by 5 a.m. so we can make our work early or something like that. So it's, you don't need codes or algorithms to do that. Pretty much you can just study to make such decisions. But an aspect of data science where you automate your process by giving some lines of algorithm to your system is machine learning.
Wow, thank you for that perspective. Jerry, you want to say something?
Hello.
Please go ahead, Nike.
Okay. So saying data science is machine learning is like saying data science is simply data processing alone, or saying data science is data visualization. So sometimes we may have to analyze data that we involve using machine learning or detailed analysis. Sometimes the data analysis may not need those deep machine learning programs. So it depends on what you're analyzing. So machine learning can be an aspect or a part of the process of analysis. So saying data science is machine learning means we are trying to define parts of data science. It will not give us the holistic view of what data science is.
Yes,
thank you.
Holistic view of data science. Thank you. I like that. I like the way you succinctly put it, that saying data science is machine learning. It's just that we will be simplifying the whole process. We'll be reducing data science to that, but data science is much more than that. So thank you for that perspective.
Yeah,
Chris,
just before.
Sorry, okay, Chizu or Elizabeth.
The guys raising their hands, Chris, Mustafa, and Kende can put down their hands, so we know new people who might want to speak.
Well, thank you, my loyal class captain. See, Chizu is on point. Please raise your hand if you want to ask question. Mustafa, please go ahead.
Yeah, so I think the fundamental difference between the data science and machine learning is the learning part of machine learning, where the data is not, the inference has to continuously learn and to improve itself. I think that is in data science, once you have your model, you run it and then you get your information out, you are pretty much done, right? But in machine learning, you are always trying to improve the model, try to see how it can learn by itself autonomously. So I think that is the fundamental difference between the two fields.
I'm not sure. Data science is, as you would see, it's not something that like you just feed forward. You do this and then it's done. It's always there's always some feedback loop. You know, like you get some new data, you try to improve. Maybe something the hypothesis you had was not exactly what you saw after analyzing the data. Then you need to kind of like improve the whole process. So it has a feedback loop somehow. But yeah, thanks for that perspective as well. Elizabeth, please go ahead. Oh, Sean, you're already unmuted. Sean, please go ahead.
Can you hear me, please? Hi. Okay,
yes,
I think machine learning is sorry about my voice. Okay, machine learning is like a subset of data science. Like from what I read from the material on the go. Okay, machine learning basically is about developing new algorithm, and data science is a combination of several techniques, machine learning, big data, and all. But we can't just say that they are the same. So one is a subset, or maybe one is a superset of the other. Data science is a superset of machine learning.
Yeah.
That's it. Thank you.
Thanks, Elizabeth. Okay, thank you. Benedict, you want to say something as well?
Yeah, can you hear me?
Yeah.
Okay, I feel that data science is a broader view Like
Just a
broader
moment,
field.
Benedict, could you be more audible? And why at it? I
We have
think
some
Elizabeth can
messages
now
on.
put down their hands.
Can you hear
Thank
me clearly?
you, Chizum. Yes, it's better now.
Yeah.
Okay, I said like data science in a broader view and all that because one thing, data science involves a lot of process. We have data analysis, machine learning, collection, and everything. But machine learning now is a subset of data science. So you can't say a subset equals to the main set and all that because you can't say that learning is equals to data science because data science is like the whole view and everything. So
Thank you.
yeah,
So go ahead. No,
just
continue.
I just feel like okay, you can't say the main thing because it is subset of the main thing and all that because machine learning is under data science, so you can't equivalent it to both of them and all that.
Yeah, well, yeah, I agree with you. I'm going to jump into the chat as well to quickly look at some of this from your colleagues. So Desiga says that emphasis is put more on stats in data science than in machine learning. Typical profiles working as machine learning engineers are from the CS background, while data scientists come from science and business background using START and business acumen. Is that still the case now? It seems like many people just come from different background. For example, like I do machine learning, and I'm from like mechanical engineering. Maybe is it the same? Like I wouldn't necessarily say that I have a CS background. I didn't study computer science. And I know people that do machine learning, that researchers that come from marine science or something like that. So it seems like it's blur, like the field where you come from does not seem to matter these days when it comes to like machine learning or like AI and whatnot. But yeah, thanks for the perspective, Desiree. So there's another one that says, Laulu said that I think there is machine learning in data science. Definitely there is. And Kenny said, because machine learning builds algorithm to learn, yeah, data science make use of machine learning tools. Absolutely. Data science is not machine learning because it is much more. There are aspects of data science that does not necessarily need machine learning. I would also allude to that. Data science is just a tool used in machine learning. I don't, nah, I don't think so. I don't think so because like if you say it's just a tool used in machine learning, then you're saying that machine learning is the superset and data science is just like one component that you use in, but that would not be correct from everything we just discussed so far. I feel machine learning comes under data science because data science is in machine learning due to the fact that it is broader field. Yeah, Benedict, machine learning is a super subset of data science. Okay, yeah, so if we still have a lot more. Again, I will read all of them, try to like see if I can put them all in this blog post for this week. It will be nice so we can continue to like read it and other people can see what we think and what we don't think data science is. Yeah, so thanks everyone for contributing to that. That was nice. There were other hands raised.
There was two people and they had their hands down again.
You don't want to talk again? I'm sorry, you can still talk. Okay, it's okay. Probably, yeah, if you want to say something, feel free to do so. And yeah, Sean, go ahead.
Yeah, they already said what I wanted to say. Like,
okay, I see. All right. So we'll try to do DRY, not repeat ourselves. We'll keep it dry. Don't repeat yourself. That's one like it's a programming thing. I was just thinking about that when I was preparing for this class. Yeah.
So I wanted to say data science. Okay, like machine learning is a subset of data science since machine learning is dependent on the outputs of processes of data science.
Yeah,
So that
yeah. One can think of it as that way because, of course, if you're just like building machine learning algorithms, or you need data. Oftentimes, we machine learning thinking, we kind of like depend on data that we assume the data is already cleaned. That we don't do things like data cleaner, and then we work on already prepared data. So who does that job? So yeah, it's definitely true that machine learning, you depend on all of these components from data science, from the other aspects of data science. So let's go into this material. So basically, it said that machine learning involves computation and statistics, but it has not traditionally been very concerned about scientific question. And if you remember, we go back to our initial definition that, oh no, okay, sorry. Let me mute my Slack. So if we go back to initial conversation where Tayo was like told us about what science means, and he said it's the intellectual and practical activity encompassing the systematic study of the structure and behavior of physical and natural world through observations and experiment. So here we are saying that machine learning does not necessarily concern itself about answering scientific question. Of course, like researchers ask questions. Like, I mean, if you're doing some data, like some machine learning work or something, depending on how sophisticated what you're trying to do is, machine learning, you just like working on algorithm, you're doing your thing. But if you're working as a researcher, you're always asking scientific question. So then you're not just like building algorithm, working on algorithm. So that's like the differentiating factor here that we will try to capitalize on. It's the fact that data science is much more like ask more scientific question, is more concerned with asking scientific question than machine learning is. Like, I mean, if you think of machine learning as just algorithms that extract patterns from data. So machine learning has heavy focus on fancy algorithm. As we would see, like as we proceed in the cohort, we will definitely be introduced to a lot of machine learning algorithms, and we have a better sense of what we mean by fancy algorithms. But I like this comment here. It's like, but sometimes the best way to solve a problem is just by visualizing the data, for instance. And someone mentioned it on the chat, where he said that if you like the things you do that is not automated, like you wake up, you put some things together or something. You mentioned that it's data science, but the fact that like if you don't, it's not automated does not make it not be data science. So it's just about you like coming up with some question, gathering data, even using Excel to gather data, to look at some statistics and everything, and visualize the data and all of those things. That's, you're already doing like data science job. Like that's like what it is basically. So it's here we're saying that sometimes the best way to solve a problem is just by visualizing. It's just looking at the data. What does it say? What can I see? But if you now get to like much more complicated data, there you cannot infer much from just looking at them. Then you want to be able to programmatically make some decision or some prediction on the data. Then you move into like this fancy algorithm, like things you can do. Then you go into machine learning, you go into deep learning, you can like move forward. But in general, you just want to understand data. A lot of the problems that like some businesses have, it's just even understanding what the data means, just visualizing it, just looking at the data. How many customers churn or did not churn? How many males do you have, females? What are the statistics in your data? Can you query the DB? Which customer has not been active for the past couple of months? you understand, what can we do about it? How can we get this people? How are we measuring the statistics? You know, we've not even started working with algorithm. We're not doing things like logistic regression or something. We're not making prediction yet. Just trying to be one with the data, understanding the data. So, and here you can see, when we think about data, so Professor Kota was like, you know, he has this nice plot to kind of like help you further understand that a lot of the problem that requires machine learning, like state-of-the-art machine learning, like deep learning and everything, it's about, according to him, it's about 5%, very, very small. A lot of problem that is solvable with simple machine learning technique, like linear regression or anything, it's about 45%. Then we have unsolvable problems, which according to him is about 50%. I mean, I don't know where he got this resource, this information from, but you know, I don't recall like maybe there was a link in the notes, maybe I missed it, maybe he put the link there, but I trust Professor Coulter's statistics because I trust him as a renowned researcher. I know he's done his research, and I know that you know, he's drawing this information from his experience and from his research. So yeah, this is just to let you see that the problems require instead of the art. Some of us might have had, oh, this state of have the deep learning model, and you're capitalizing on, you know, computer vision and everything. The problems out there that you want to solve, most of them are probably most likely solvable, but using simple machine learning. So this is to tell you that it's really, really important that you pay attention to all of this basic, try to own it. Then you can now do fancy stuff on it, like build upon the knowledge that you gain from this get-go. And so he also now mentioned that data science is not machine learning competitions, and I wouldn't want to like you know, go like, let us have a broad discussion on this, because the major point is fairly easy to see. So how many of us know of Kaggle? With a raise of hand. Okay, good. Yeah, thank you. I'm glad that some of us have knowledge of Kaggle. Okay, so thank you. So basically, Kaggle is a machine learning competition website. Abi, is that how we should define it? So like, you go to Kaggle, you find some problem, you know, understand, it's usually competition. Some are like some are paid, you have prizes. Some are competition that like you've done before, there's no prizes, but you can still use it to practice. So some companies would come with their problems, they'll put some money. As you can see, like this problem here, still defects detection. They'll put the problem statement, the data and everything, and then the amount that they will be given to the winner. Here is $120,000. And now so you, as a badass machine learning something or data science something, you go with your skills, you download the data, you understand the problem, you start like using all of your fancy visualization and everything to solve the problem. And once you have a prediction, you submit the prediction, then you land on the leaderboard. So there's a leaderboard. You also see other people that are competing for that $120,000, because who does not want money? So and that is, a lot of people actually win a lot of money here. I've not done competition on Kaggle or anything, so I don't know much about how to. I mean, I've done some, but yeah, I've created competition, but I'm not a Kaggle competitor. But I know some people who are, and then like, you know, some of the Kaggle competition that we've also run, like, and some people have won the competition. So it's a way to flex your muscle, to improve your skills. So if you're like with Kaggle, you would pick up a lot of skills very quickly, a lot of hacky solutions to do things and everything. So yeah, I definitely encourage you to check out Kaggle, and also Zindi. Zindi is the African version of Kaggle. So, and you know, they are fantastic, doing fantastic work. You see a lot of local problems, especially to Africa on Zindi, and also monetary, of course, like you can win money from it. So within your group, as you grow, and if you have time, you're really excited about, competition and things like this, if that's, you're that kind of person, then you can form team, amongst yourself, try to just enroll in one of this competition and practice and use some of your skills. It will definitely help you learn faster, to be fair. So you should think about it. So coming back to why data science is not machine learning competition, what Professor Kota was trying to say here is that in machine learning competition, you're not doing things like gathering the data. Of course, you look at the data, you remove some NAs, some missing values and all those, imputation, but there's not a lot of cleaning being done. Like it's fairly reasonable data that they would give to you. Of course, some data sets might need much more cleaning in some computation, but Professor Kota is of the opinion that if you don't have all of those, you're just like optimizing for a metric on a fixed data. So then it's not necessarily, it doesn't solve a desired, it's meant to solve a desired business problem, but it may not ultimately solve that. It's not a given that you're solving a desired business problem. So
I did one time like that too, but then this was when graduating list came out. Now their name, I think the first day that it came out, their name didn't pop up. It was like Ms. Munshala said they will solve it, and I was supposed to ask the next day and I forgot. So I don't want to go back and go and ask again. It's not going to be like I just want to know. You know what these people are, then I feel like you just want to know because you want to help them or something. So I don't know. Can you just reach out to him? It's not like at least we were friends.
I think that was a mistake, right?
Admin should meet everybody.
It felt like you wanted to be close to what you're talking about.
Exactly. That was why I was listening. I was not sure, so I didn't want to interrupt. Oh my God. Anyway, so that was fun. I see a couple of hands raised. I'm going to call you now. I'm sorry. I just saw the hands raised now. But yeah, so basically, what Professor Coulter is alluding to is that data science is the iterative cycle of designing a concrete problem, building an algorithm to solve that problem, or determining that this is not possible. It's possible that you can't solve the problem. And then evaluating what insights this provides for the real underlying question. So like machine learning competition does not necessarily do all of that. And in fact, if you're a Kaggle master or anything, they know what works. Like you do an ensemble of like these algorithms, you put them all together, you'll get a high accuracy. You're always optimizing for a metric. You want to always be on top. And so they all have their own place in knowledge, like in helping you hone your skills and become better. Because at the end of the day, anything that is like science, it helps you, it's like an art. How can you innovate? How imaginative are you about some of this? But you don't have to be so imaginative. You just have to read a lot of like exposed to a lot of materials, a lot of things, and then you voila, you're imaginative so much. Anyway, I digress. Joseph, you want to say something? Please go ahead. John, Joshua, any one of you can go first. Your answer is.
Hello, John, Joshua.
Maybe it was a mistake. Okay.
You asked everyone that has used Kaggle to raise their hand, so I suppose they raised their hands.
They have not lowered their hand. Okay, no problem. Okay. But what do you guys think about Kaggle? For those of us that have used it, how do you feel about the website?
Let me go.
Yes, go ahead.
I think Kaggle will make you feel bad.
Why? How do you mean?
Intimidating,
I think
very
Kagu
true.
will make.
It's intimidating. In what
So
way?
for like I think you as a beginner looking through the site, if you are not strong, you will just dump data science.
Oh my goodness. So it's
Because
very
especially when you see people with masters, people with the expert level thing, and then you look up and you're seeing yourself like novice, and they don't even start with novice. After novice, you now come to beginner. After beginner, you now come to learner, and the rest of them. So,
Another
so
part is
warning
checking
yourself.
people's notebook. Checking people's notebook could be really frustrating, especially when you go to grandmaster's notebook to go and check how they, analyzed their data or came up with their lines of code. And then you've been bragging about your knowledge of Python, only that you see a notebook you can't even read.
Goodness.
And then you come to terms with the fact that, okay, what is this? And you call the bosses in town and then you say, oh, this is TensorFlow. Wow, TensorFlow. Okay, so how does TensorFlow works? And then you're like, yeah, it works now. So pretty much, yeah. So it's quite
Like,
intimidating.
it's a framework.
Tejun,
Yes,
is this the time where I market Zindi?
yes. Go ahead, Femi.
Yeah. So Zindi is actually like a platform for African data scientists. So like Zindi is much more, I think, beginner friendly. So if you really want to own your skills and you want to try it like with people, like something much more beginner friendly, I think Zindi is a good platform. And yeah, actually I would recommend Zindi. So their website is Zindi.Africa. I think it's on the chart.
Yeah, and it's actually a wee. It's like
All of us,
it's a black person like you. We're all like learning together.
So I definitely know more people that have won on Zindi than I know on Kaggle.
Yeah, even from AI6 Lagos, like lots of people have won money, won some cash on ZD.
Yeah. So that's a good.
By the way, when you guys start winning money, just send AI6 Lagos some money. It's like, she should use it to define girl. Like my goodness. I'm just kidding. But to be honest, besides winning money, it's a good motivation. I mean, I need money, everyone needs money. Why not? Like, you put in the effort. But it also would help you kind of like it pushes you. You wouldn't you might not even understand everything about machine learning, but you're still able to use a lot of tools. Do you understand? I mean, it's definitely a good way to get yourself continuously motivated. Like I said, I don't use Zindi or like Kaggle that much or anything. Like I'm one of these people that just read and read and read, and like it's my style, but it's not. I also know that it's not the most optimal. Because then I spent so much time on theory. You get what I'm trying to say? So I spent lots of time, and like I found out that every time I try to like maybe this thing I'm trying to read, I look at the code as well. It's my learning process is faster than if I was just trying to read that piece of theory without looking at how it translates to code. So it's definitely very good for you that as you're reading and as you're like learning the theory, you're also trying to apply it, because that would help the way you think about the problem. It will solidify it better. So I would encourage you to hop on some of these. Wait, now who's frying plantain?
I just signed up for Zindi now.
I'm sorry.
Sorry, Ezekiel. I'm sorry. Elizabeth, was that you? Would you like to say something? Tayo, your audio is super low. Could you please?
I just signed up for Zindi now.
You signed up for Zindi. Okay, great. By the way, the great thing about everyone that is here is that we are going to be on this journey for the next 16 weeks. So you're all like learning this thing today. So if you find a competition on Zindi that you want to apply to, some beginner friendly competition, ask if anyone would like to join. You get like form a team together, just kind of like fool around. Nobody's going to beat you. And if the thing does not work, you leave. It's not good to be leaving all the time, but like, sometimes it does not work. You are trying, you understand? Like, you cannot die. But
don't leave our cohorts training.
But don't, if it's too hard, don't mind Femi. Like, but if it's too hard, you can relax and come back. Life is not hard. But I'm just saying that. I'm just trying to say that you have the opportunity here. Like, I for sure know what it means to, like, what it feels like to be learning. Sometimes it's really hard. And I understand what it is. Like, machine learning is broad. So many things is going on. You don't even know. At some point, you're confused, like, what is what and what is what. But we are all doing this together. We all have different experiences. So do you understand? So capitalize on that. Do you understand? So if once you're starting to get confused or something, just reach out. If something is exciting to you, you find out, even though you don't understand how it's going to work, just reach out or ask. Before you know it, then other people will start like giving you inputs, and that's how you improve. That's a smart way of improving your skills. Do you understand? Yeah, that's all I want to say about that one. So let's move to the last part that says that data science is not statistics. And I think we already had lots of conversation about this statistics and machine learning. So here it says that analyzing data computationally to understand some phenomena in the real world. Then you're like, yeah, that's statistics. But as we've already argued earlier on when we were having these conversations, the statistics, at least the academic type has evolved a lot more along the mathematical or theoretical frontier. And we talked about this specifically where we said that, we can think of math as the overall and statistics just like one part of it. And one of your colleagues mentioned that math is much more theoretical, like proof and so this is like the argument here that it goes along the mathematical, but not many statistics courses have a lecture on, say, for example, web scraping or data processing or so on. This last point, I think it's a point from Professor Kota. It has to be a point. He's like, statistics uses R, why data scientists use Python? Clearly, there's this recurring argument, like statisticians and data scientists. Some data scientists that use R, they'll be like R versus Python, and Python is a programming language that is very robust. Like you can use it in the programming regime where you're building website and everything, and you can also is heavily used in data science, and it has lots of tools. R is also a programming language, but for it abstracts a lot of things. I've used R a little bit, but I wouldn't call myself R programmer for sure. But it's like, from people, they say that it's very easy to use. Like some tools, some visualization tools are massive in R that like it might be harder to put them together in Python and all of those matplotlib or Seaborn that you want to use in Python, which, by the way, we'll be doing some introduction to in practical session. I think later this afternoon you'll be introduced to like data science notebooks, and maybe you can already see some of these things introduced there. Anyway, that's not, I think, I thought that was the last one. So the last one here says that data science is not big data. And this is coming from the fact that a lot of people have this notion that, because data science, like big data is something that cannot fit into memory. Once you have something that cannot fit into memory, that you have to use things like Spark or all of those tools, which some of them we would also introduce, because the theme of this cohort is like end-to-end. We are looking at ML ops, so you would mostly be familiar with some of this at the end of the cohort. But here we're trying to say that sometimes in order to truly understand and answer your question, you need massive amounts of data. Yeah, sometimes that is true, but sometimes you don't. So Professor Kota is saying that don't create more work for yourself than you need. You just kind of like, if you don't need that tool, you don't need to like start delving into it. Some tools that you already have is enough to solve your problem. Sometimes you don't need that much data. Small data is already enough. Sometimes you need a lot of data. So that's what this part is trying to say. So now we are back to what data science is. And then here you can already see that we talked about this from data collection, data processing, exploration, visualization, analysis. You can see that machine learning is a part of the tools for data science, not the other way around. And then once you analyze, then you want to maybe have like some insight or make some decision, like policy decision. And it's not just a feed forward, like you're not just going from data collection to processing, visualization, analysis, and insight. You also sometimes need to feedback, you get some insights, you have to go back to machine learning to tune something, or you get some insight, you go back to visualization to understand something, or you go back to data collection to make the data much more robust. So it's this thing where you have to always come back. There's this feedback loop in the process. And I also got some more charts for you to look at. So you have data science here, you have things like data research, data technology, statistical computing, statistical modeling, visualization, scientific method, real world application, data consulting. You can see when I started, I told you that I'm not a data scientist because the only thing I do at the moment is in this area, machine learning. So it's to be a data scientist, you're expected to be able to do all of this. I mean, I lied a little. This is not the only thing I do. Because I'm being recorded. I play a lot. I do a lot of visualization as well and data processing, but data collection I don't collect. I usually work with data that are already collected. At least for my research, like there's already data. I just get the data. And I don't do much processing. I just visualize, try to do some visualization and exploration, but definitely not doing things like cleaning or anything. And most of my work is focused on analysis and the algorithms and understanding and, formulating research question, testing some hypotheses, changing some hyperparameter, seeing what happens. So definitely much more focused on this and trying to get insights from this process. So but from this chart you can see that we need much more for us to be able to comfortably say that we're a data scientist. And I also found this chart interesting. It's data scientists must have skills, things like math and statistics, machine learning, statistical modeling, exploratory data analysis, clustering, regression analysis. I mean, it seems like there's a lot of things you need to learn, but a lot of people learn on the job, right? So you just need to hone your basics. And that is what we are here to help you do. By the time you finish this cohort, if you are honest with yourself, finish it honestly, you should be able to get a job as a data scientist or machine learning engineer, if you may, because you would have learned all of the skills that you need to work on the job. So see, the thing about scientific thinking and all of those things, some of them come with experience. The more you do, the better you get. Then you also get familiar with a lot of tools. You have a lot of data scientists in your network. They share their code. You read what they have to, they share. You also contribute back. You share your code. Someone else reads it. And that's how you improve. So, but you just need to make sure that your basic is good. Your foundation is good, because you need that sanity check. So programming, of course, you use things like data visualization, yeah, you need to have like some fundamental of computer science. That's not much, just some database management. You can always get all of those skills, you know, as you find something that you think that you don't know what it is, you can learn about it, you read up on it and improve your skills. So Python, we'll definitely be using that heavily, especially for the practical session. Big data, I don't know what this means. I mean, I know what it means. It's trying to say that you need to be able to work with big data, but not everyone works with big data, for example. So it's relative. So you also need to have communication skills, like storytelling skills. Those are like add-ons. It's good for you, especially if you're working as a part of a team. You know, the way you can present your results, present your findings, and you know, crystallize your thoughts. It's always good to have that kind of like skills. It would be helpful for you. So yeah, then domain knowledge and soft skills, those are like add-ons as well. It's good to have, but not every data scientist like has this. But it's always better. A very good data scientist would have this, basically. So now we have, oh goodness, I knew I was going to go over time a little, so I'll try. So we have a few data science examples. Here is the first one, gender language. And I think this is interesting because, wait, are you guys still here?
Yes.
Sure.
You're talking so much and now I feel weird.
Yeah.
Okay. Okay, thank you. So there is this gendered language in Professor. We'll quickly go to check that thing out. So the funny thing about the interesting thing, not funny, is it funny? Funny, interesting. Oh, English. The interesting thing about this thing is that it's not, it does not do any fancy algorithm or something underneath. All it does is like just summing up the number of queries. So the gender language teacher, like if we go to this pro gender now, I don't know what's happening. I'm trying to move. Okay, yeah, I think this is it. It's in my internet. This is supposed to be better. The thing is acting weird. Sorry. I went to full screen. Now I'm trying to find out how to come back. I wrote the command down somehow because I always forget it. Okay. Where did I put it? Command Shift F. Yeah, I'm back from full screen. So yes, this is where we are. What this is doing is that you go to this website and you can write anything, and it would cluster the the keyword that you put in. It will cluster it across the different departments, whether or not the person is a female or male. So the charts let you explore the words used to describe male and female teachers in about 14 million reviews from ratemyprofessor.com. So you can enter any other words or two-word phrase into the box, and below you see how it's split across gender. You can see that this thing is not doing anything machine learning right now. You just put a keyword and then it just does statistics, sum all the number of time you find the keyword that is used in the female with the female professor across different those departments like psychology, language, and everything. And you do the same for male, and then you plot the chart. That's all. Finish. And it solves a problem, right? Like now you can just like see if people think that professors are funny or not. Like apparently from these charts, some people, like a lot more from the data that they have, a lot more people think that the male professors are funnier, like because the funny is much more used in the male to describe the male professor than the female professor. Which, I mean, of course, we can come into like things like talk about bias and everything, which might be that the data is biased, but the main takeaway from this is that simple thing like this, you can already start seeing results. This is something that you can also build. You don't need machine learning to build this thing. Do you understand? What keyword do you want me to put here? What should I try? What are you curious about?
Strict.
What? Strict. Okay. Oh no. Does this agree with what you think? That female professors are strict, female teachers are stricter.
Oh, we are being recorded. Let me not sing.
So we are being recorded.
Yes, they are.
Yeah, I mean, shy. Yeah, yeah, yeah.
Teju.
Yeah.
Hello.
Go ahead.
Can we have something like trustworthy? Can we have something like trustworthy?
Let's try it. Trustworthy.
Let's see who is trustworthy.
We know now.
Oh, it's almost the same for everyone. It's scattered. Should we try another keyword?
Mood swing.
I'm not gonna try that. Don't get me into trouble. You want to start that?
Biased.
Biased. Okay, let's see. Biased. Well, it looks like they are both biased. I don't know. We have to take
annoying.
This. What?
Detailed.
Okay, detailed.
Now they're looking forward to help them out.
What do you mean? There's no them versus us. We are all together here, right? But yeah, you can see all of this.
You're trying to start a mini Twitter war here.
Yeah, no, this is not that. We're not trying to do gender war. So basically, this is just to show like the keywords, and we can already see that this would be biased, right? Like if people think a lot of female teachers are like strict or something, or like they say they think a lot of male teachers are funny, like how do they define funny? Like how do they define strict? And all of those things, I don't know. And we are not talking about bias and societal impacts, yes, which we will talk about at some point in the course of the cohort, because I believe it's very important. You cannot get out of this cohort without at least being exposed to some of these societal impacts that machine learning can have. Yeah, so this is one thing. Again, this is something that you can already build, right? We have software engineers amongst us. We have different people with different skills. Get some data. What is the simplest thing you want to do? Just kind of like mess around, and people would use it to teach. Like it can be funny, like it solves some problem. And it brings me to the second, like this quote that says here, right? It says the greatest value of a picture is when it forces you.
Sorry, Tenny.
Sorry.
Teju, sorry.
Yeah.
You said get some data. Can you just point out a way to get voice data if I actually want to get some voice data? Is there any way I can do that?
So what kind of voice
voice
you want? Because for example, my research that we did, we have some data already on SaltyDB where we collected different voice data. So I don't know if that is Zenodo. I don't know if that is the kind of voice data that you need. Right here, we have about 919 voice sample, which was so kindly donated to us for one of the projects I'm working on. It's called SaltyDB. And we have a web app where people can donate your voice. So you can also help us. You can still put your, come in, log into the web app, and then just read. There's always a sentence there, and then you can read the sentence. And this is definitely going to help us in our research. In this data, you have something like the native language of the person, the language they're fluent in, and the speaker ID. So if I don't know the kind of voice data that you want to collect, this is one. But if you are not satisfied with that voice data, there's all other voice data, especially for, let me try to, right. There's also another on Nigerian English data. I think this was from Google. Google. I have the data. Let's see. My search is not comprehensive enough. Yeah, I think this is it. Cross-site quality. Yeah. So you can also come here. I've downloaded this data for sure, and it has data set of both male and female. They were just like also reading some text. You can also see the annotated text. So if this is the data you're also looking for, you can get. This is still not satisfactory, I'm sure, like if you look at Zenodo itself, there are a lot of different voice data as well that might be interesting to you. If you're looking for machine learning data, you can look at. Yes, go ahead, please.
Okay, you should be aware of your time. You should be finishing up now. Your time is
Yeah.
like, yeah.
We still have like 15 minutes. We have 30 minutes before the next class, right?
Okay.
So me and my students are enjoying each other. I mean, you guys want to leave now.
Okay. No, there's that. Then there's also another important information that I need to release now. So in order for us to take attendance of this class, all you have to do, just do me one favor, everyone present in class. Go to your team's Slack group. It should be in your team Slack groups. Go to your team Slack group and indicate that you were present in the class. Just go there and indicate that you're present in the class. Maybe I don't know. Maybe
now,
a good.
Isn't now, sir?
Yeah, do it now if you can multitask. Do it now. So just indicate that you're present.
Femi, I'm confused. So how are we going to collect that data? Do you remember that Slack would, after a couple of messages, it will disappear?
No.
How do you want to collect the data?
This is temporary. So in the future, what I would advise you to do is whenever you join this is temporary. This is just a temporary fix.
Yeah.
Number one, I'm using this for two things. I'm using it to ensure that everybody here is present on Slack, and that everybody here also has access to their team's Slack group. So each of the teams that you belong to has a Slack group. So I want to ensure that everybody here can find their team Slack group. Do you understand?
Okay,
yeah,
I understand.
That's why I'm doing this.
All right,
so go to your team Slack group in case they are present. In the future, whenever you join the Zoom meeting, please put your full name on the team meeting.
Yeah.
The person in charge of taking attendance is going to look for your teammate for your full name on the participant list in the future. But for now,
I think there's a way I can make sure that the guests sign in with their full name. I will look into that. I think Zoom can ensure that. So
okay. So guys, for now, I just want to ensure that everyone on this call is on Slack, and that you can have access to your team's meeting. I just want to be sure that you guys are all present in your team's Slack group, that you all are aware. So I want you all to go right there and indicate that you're present. Yeah. So thank you very much.
Well, thank you for me. Does that answer your question about the data? I was also going to say that if you're looking for machine learning data, like there is machine learning repository, like where there's a lot of data sets that you can play with. Do you understand? So you can just go to UC. I mean, this is the one I use because I have some data I use from here, but there are also other repositories, which brings me to one of the things that I wanted to ask you guys about, like this idea of looking for different repository of where data is. It would be nice to collect it together as maybe like put it as a list. So I was thinking that if anyone was interested and they want to, have some projects where they want to like collect or like all of this African-based data sets and put it in a repository, they can do that. You can just come to like AI6Lagos repo, or you can also do it on your repo. But if you want to donate that repository to the community where you'll be doing it, like on the AI6Lagos organization team, so you can just like create a repository. So you can create a repository and you can start putting information about the like different data sets. Let me give you an example. So one of my colleagues, George, has a repository that he is using for his like project. So he called it Tiny ML Papers and Projects. All it does is just, it collects all of the awesome papers from Tiny ML from the onset. And a lot of people found this repository useful. Like maybe someone is interested in Tiny ML. Instead of trying to Google everywhere to find related paper, they can just come to his repository and try to like look at different related paper if there is a code and go there. It definitely solves a problem. You can see he has about 210 star. If you find it useful, also go ahead and star or share it. So this is the kind of things that, you know, it solve problem for someone, maybe not everyone, but for someone. We've always had this, like, how can we find African data sets and everything? Every time we have to Google and find it. So it would be nice to have a repository that is continuously updated, that, oh, if there is new data, we just update with new data. It would help some people, definitely solve some problems. So this is just to put it out there for anyone that is interested. You can think about it. So does that answer your question about the data, voice data that you asked?
Thank you, Alice. Thank you.
Please, if it does not, let me know, and we can find solution. So since we officially ran out of time, and I'm sorry, another project I want to mention is this. This is actually from a student, one of our students, Chizurum Olorondo. It was also my TA, teaching assistant for last cohort. He's a fantastic guy. Chizurum means the world to me. Like, I really enjoyed working with him. One of those people that put in all of their all to what they are doing. He ensured that the student understood. He would even take like some extra classes with them to explain something to them. So Chizurum's fantastic. So I wanted to mention, he built an end-to-end data science project. It's amazing, and he detailed how he did it. So the goal of the project is that he wants to simplify and limit the time it takes for an NBA fan or a curious individual to find out useful facts about current active player in NBA. See, goal stated. What do I need to solve the goal? To solve my problem, to reach this goal? Or all it did, the first component, it did data collection. Then it did some put the data into SQL as a database. Then store the data in the data lake, which is the second component. Then he did things like extraction, transformation, and loading. And then he built a prediction, like outlier prediction system, which is the machine learning part. And then he deployed it on Heroku, which is the deployment part. So you can see that it followed all of the pipeline for that we've discussed that entails the data science work. You should definitely look at the go to his website. I think this is slow. Can everyone still hear me though?
Yeah, sure.
Okay, thank you.
Yeah.
Yes, we can hear you.
It was not my internet that is slow. Okay, yeah. So definitely go there to check it. And by the way, this slide that I'm presenting to you right now, I've actually put it on GitHub. So you can go to GitHub. We have classes, cohort 7 classes, and you can just go here. Or better way, how to find everything about this cohort, very simple. Come to AI6Lagos GitHub, go to Teams. It might look differently than it is for you because I'm an admin on here, so I have access to everything. So come to Teams, you click on cohort 7, you will see something like this. Then you go to repositories. You will see all of the repository that are linked to cohort 7. This is the classes that I just talked to you about. Click on classes, come here, click on week 1, cohort 7. This is the intro to the intro DS that I am presenting to you right now. You can download it and look at it. I've put some explanation that the slide is gotten from this course. So you have to cite the course if you need to take something from it. Then the complementary slides that I consulted as I was preparing for this class is that I also found that the slides are interesting. You can look at them. They gave much more explanation in some introduction to data science. So add these 2 slides as well. I thought that might be useful for people that are curious or they want to create a slide themselves and they're looking for resources. So that's it about it. If you're in the afternoon, we have practicals, and you can also find all of the practicals here. Click on practicals. You would come here, you'll find the practical that you'll be working on in about like 15 minutes. I'll try to release you very soon so that you have time to take a break or eat or something. So this cohort 7 structure, I've shared it on Slack already. This is where you will find everything you need about the cohort, or that's what we hope that would be. So you can find all of the information about the cohort, the subgroup, the team responsibility that Femi presented last week, what you need to earn a certificate, the curriculum, all of the lecturer. Next week, we'll be having Tayo take us data collection. You can already look at the slides. Tayo will most likely have his own slides with the things that he wants to teach you, but he will still be drawing inspiration from these slides and notes. And if anything changes, it's going to communicate with you. And you can also see all of the rest of the tutors that we already have. And for practicals as well, we have a list of it. I think possibly someone updated it and we broke something. I will fix it. It's also supposed to look like a table, and you'll find the practicals that you need for the cohort. So, and please give us a star if you would like. We would appreciate it. It gives us visibility. So that's about, it was just a quick administrative comment. So yeah, that is the last example, which you can look at. It's the 5038. It's also a data science application where they use it to forecast the US election. You can go to the link to read more about it. This is just to tell you about like some data science problems and tools, data science solutions that are out there. Your Google search uses machine learning in depth. It's also like data science tools, like your Google Translate that translate from one voice to another. So it's ubiquitous. It's everywhere now. But again, you have to think about data science as in the broader perspective of the science of the data. And so, this is also another example. I think this is important to mention. This poverty mapping, you know what they did? So they wanted to know what community in Kenya and Uganda would benefit most from charitable donation. And they decided to do that by looking at satellite imagery. So they realized that a lot of houses that have thatched roof are mostly poor houses. So, and if you have like steel roof or something, maybe it's from a rich region. So they just use satellite imagery to predict, use that to predict thatched view, and then use it to estimate the level of poverty. See, that's data science you're looking at. And so that's it about today's course. We made it to the end. Thank you for making it interactive. I've already mentioned a few things. So the learning objective for this course, after you take this course, you should be able to understand the full data science pipeline. At least we'll try our best, and be familiar with the programming tools to accomplish the different portion. You should be able to collect data from unstructured sources and appropriately put them in database. From the next class, you should be able to do that, data collection and scraping. You should be able to explore and visualize your data, analyze your data rigorously using a variety of statistical and machine learning approaches. So these are the topics we'll be covering. Some of the topics, you can find the rest here. We'll talk about next week. You will be going through data collection and scraping, relational data, visualization, and you can say that you wouldn't even get to machine learning until like the 7th week. So it means that we'll spend considerable amounts of time trying to help you get into this science mode, like understanding, visualizing data. And we'll also be covering a couple of practicals. Like today, you talk about data science framework. Next week, we will do web scraping, data labeling tools, and introduction to pandas and all of those. And the main resources we're consulting for this cohort would be this datasciencecourse.org. have a look at it. There are assignments on it, even though we are not doing those, as we are not making the assignments compulsory this cohort. It's good for you. All of the resources always have notes. Those notes are incredible. It's very useful. I cannot tell you enough. So always consult those notes, especially when you have a question or something. First, look at those notes to see if you can find some new skills that you can adapt to your problem. And the other resource, which I also find excellent, to be honest, is this machine learning at VU. It's a lot more about machine learning. So once we start machine learning, we'll be consulting this resource a lot more. And you can also find the details there. It has a video, it has a playlist as well, which you can watch the video. So that's all I have for you for this this talk. And in 2 minutes, I just wanted to mention 2 other things before we come to questions, if you have any, is that please, we are trying our best to make everything social, and we also want to visibility on our students, on our work. We have all of this social media. Please feel free to follow us on Twitter, LinkedIn, on YouTube, our GitHub repository. Try follow us, please, if you can, like Medium, Instagram, Facebook. We have all of those things for you. Please follow us. And for Medium, if you want to write an article and you want to put it here, we accept articles. Please feel free to write about what you're doing, or like write it, and then you can read more articles. Like I definitely have a couple of articles that I wrote here. You can read about reflection, like some of the previous cohorts. We've always tried to like write about the journey, what we learned, and you kind of like see what the class was like. And if you have article, also write it and give us like, you know, shout out to us, and then we can put it on our blog and share it as well on our social media. We try to put as much visibility as we can to your work, but this is all working together. We only, if our team is not very large, so you can imagine that there's a lot that we can do, that maybe if you would like to jump on it, you think you want to help out, please feel free to do that. This is completely volunteer driven, and we always appreciate help wherever we can get it. So, my dear ladies and gentlemen, this is where we say the class has ended. I see now that I have 33 messages. Let me quickly look at it. Is there a task to complete before Saturday? Yes, there is a task to complete, and that will be discussed in your practical sessions. I think Femi has replied to a lot of it. So, any question? We'll stop sharing my screen here so that we can see each other a little bit more. Any question?